Yes, welcome again to DC Economics. So today I'm going to take you through differentiation. So when we speak about differentiation, the first thing we need to understand here is about differentiation. Differentiation is the process of finding the rate at which a variable quantity is changing. So differentiation is the process of finding the rate at which a variable quantity is changing. So one thing you need to understand here is that differentiation is concerned with the determination of the rate of change in the dependent variable for a given small change in the dependent variable. For example, we may assume to let out x be an independent variable. Let's let be x an independent variable. And y, let it be a dependent variable. So when you let out x be an independent variable and y be an dependent variable, then we may conclude that then x and y is a function of x. X and y is a function of x. So for that case now, we may imply that the change of dy over dx is equal to the change of x that limits that is changing of y over changing of x. So for that case, the derivative change of dy over dx implies that the derivative of y with respect to x so derivative of dy over dx implies that the derivative of y with respect to x. Now, derivative or differential coefficient of function of x is generally written as dy over dx, that's the function of x, or we may write out the function of the first order derivative or y1 or dy over dx, whereby y is equal to the function of x, whereby y is equal to the function of x. So in simple manner, the derivative is the rate of change of y with respect to change of x. So the derivative is the rate of change of y with respect to change of x. Now let's come to the rule of differentiation. Now let's come to the rules of differentiation. As you can observe, the rule number one is a power rule or polynomial function. The first one is what we call it the power function rule, or sometimes we call it a polynomial function, or we sometimes call the polynomial function. So in polynomial function, the derivative of a power function y of x, derivative of the power function, that is y is equal to the function of x, is equal to x raised power of n. This raised power of exponential, as observed, which is n. So n actually is any real number. N is a real number. N is a real number, that is any x that we take out any minus 1. Now let's consider an example. For example, let's consider an example. If y is equal to x raised to the power of any, then our dy over dx will be equal to any x any minus 1, as you can observe. Now, for example, let's consider another example. Now, you are given y, which is equal to x raised to the power of any. So when you find the derivative by using the power function rule or polynomial function, this will give us now dy over dx, which is equal to, we take out 8 times x, which will give you 8x, then we take out 8 minus 1. The answer will give you that is 8x raised to the power of 7. This would be the answer. Now, if we find also the derivative by using the power function rule, and you are provided with the function that is y, which is equal to x raised to the power of negative 10, when we apply the formula, that is what we call that dy over dx, that is equal to any x any minus 1, this will give you out now negative 10 times x, that will be dy over dx is equal to, take negative 10 times x, this will give you negative 10x raised to the power of negative 10 minus 1. So the answer here will give out, the answer here will be equals to negative 10 x raised to the power of 11. That to say, this will be equals to negative 10 raised to the power of x over 11, something like this. So this will be the answer. Suppose also you are provided with another example here. The third example, that is y, which is equal to x raised to the power of 5 over 3. So when you apply the derivative by polynomial function or power rule, the answer will be equals to dy over dx, which is equal to 5 over 3 x, then 5 minus 3 minus 1. So for that case, the answer will be now dy over dx, that will be equals to, rate of change of dy over dx will be equals to 5 over 3 x raised to the power of 2 over 3. Suppose also you observe another example like this. You are given that 1 is equal to x raised to the power of negative 10 over 4. When you apply the derivative change of dy over dx, the answer will be equals to negative 10 over 4x, then take negative 10 over 4 minus 1. Now the answer will be equals to negative 10 over 4 x raised to the power of negative 14 over 4. So this would be the answer. Now suppose also, let's look another example. For example, now you're given y is equal to radical of x, the answer will be equal to dy over dx. We'll first convert out this value, write the function in an easy manner. That will be radical of x is the same as you write the x raised to the power of half. Then we apply the derivative change of dy over dx. If we give you a half times x, which is equal to half x, then a half minus 1. So our dy dx will be equals to a half x raised to the power of negative 1 over 2. When you take 1 over 2 minus 1, will give you negative a half. Now let's look on the second rule. The second rule is about this is about we call it a derivative of a constant. This is the second rule for derivative. We call the second rule, which we called out is what we refer to call the derivative of a constant. Derivative of a constant. Now for this case, now derivative of a constant function is 0. Derivative of a constant function is normally equals to 0. So derivative of a constant function is equal to 0. So suppose we are provided dy over dx, which is equal to d over dx over c is equal to 0. So the derivative of a constant function of c is equal to 0. For example, let's look at an example. If y is equal to negative 10, then you are required to find out derivative dy over dx from this function by using what is called the derivative of a constant function. dy over dx would be equal to 0, since the derivative of any number that is constant is equal to 0. The same applies if you are given y, which is equal to y is equal to 5. The derivative of a constant here would be equal to dy over dx is equal to 0. The derivative of f when a constant number is equal to 0. Now let's come to rule number 3. Rule number 3, that is what we call derivative of a product of a constant in a function. Call it a derivative of the product. Derivative of the product of a constant. Derivative of the product of a constant and a function. This is like to say, for example, you need to understand here that the derivative of a product of a constant and a function is equal to the product of the constant and the derivative of a function. So the derivative of a product of a constant and a function is equal to the product of the constant and the derivative of a function. For example, if y is equal to ax and raised to the power of n, whereby a is a constant, and a is not equal to 0, our function here that will obtain will be equal to dy over dx is equal to d over dx, then ax raised to the power of n is equal to a over dx raised to the power of xn is equal to a nx n minus 1. For this kind of function here, our derivative will be equal to a dx xn, then a nx n minus 1, as you observe. Now, let's look on the lead example so as you can understand the concept on the rule number 3, that is the derivative of the product of a constant and a function. So, for example, let's look at this example here. Now, if y is equal to 5x raised to the power of 5 raised to the power of 7, then we're required to find out our dy over dx by using out what is known as a constant, what is known as the derivative of a product constant and a function. So how do we solve this kind of equation? Now actually here the solution will be equal to now to dy over dx is equal to, take out these values over here, that will be equal to 5 over d over dx raised to the power of x raised to the power of 7. This is like to say we take out, this will be equal to 7 times 5, we take out, it will be we take out 7, then times 5, then x raised to the power of 6. Raised to the power of 6. This will give you, now this will be, is this like to say now it will be here it will be 7 minus 1. When you take out 7 minus 1, it will be now 35x raised to the power of 6, as you observe. That will be the answer. For example, example 2, let's consider y is equal to negative 30 x raised to the power of 5. Now you're required to find out dy over dx by using what is known as the derivative of a product of a constant and a function. This will give you now dy over dx is equal to negative 5 times negative 30. This will give you, it will be negative 30, it will be 150 x raised to the power of negative 5 minus 1. This will give you dy over dx that is equal to 150 x negative 5 minus 1 is equal to negative 6. This will be the answer. So this will be the answer, as you observe. Now let's come to first rule, that is linear function rule. We call it a linear function rule. So we call it a linear function rule. So under linear function rule, now if y is equal to mx plus c, whereby m together with what is known as c are constant, then dy over dx will be equals to d over dxy, that is equal to derivative change of d over dx, then mx plus c, which is equal to m, which is equal to m. So derivative change of y will be derivative change of d over mx plus c, which is equal to m. So for example, let's look at an example here. For example, if y is equal to 5x plus 10, then we are required to find out dy over dx. The answer here will be equals to now dy over dx will be equals to 5. At a constant will be equals to 5 over there. Another example, if y is equal to 10x raised to the power of 6 plus 3x raised to the power of 4 plus 4x raised to the power of negative 2 plus 10, then you are required to find out dy over dx by using what is known as linear function rule. The answer will be equals to, you take out dy over dx will be equals to 6 times 10 is equal to 6 raised to the power of 6, then 6 minus 1, which is equal to 5, then plus 4 times 3, which is 12x, then 4 times 1 is equal to 3, then plus 8x, then negative 2 minus 1 is equal to positive negative 3, as you observe. So this will be the answer. This is a constant, so any constant when you apply the derivative, the answer is equal to 0. So this is the answer. Let's come to the rule number 5. That is the subtraction rule. We call it a subtraction rule. So in a subtraction rule, the derivative of a difference two functions is equal to the difference of separate derivatives. So under this one, the derivative of a difference, the derivative of a difference two functions, derivative of a difference of two functions is equal to the difference is equal to the difference of the separate derivative of the separate derivative. Now, if u is equal to u minus v, then we actually consider that dy over dx is equal to du over dx minus dv over dx. So, for example, the derivative of minus the first function minus the first function relative to the second function. So, let's consider an example in subtraction rule. For example, if y is equal to x raised to the power of 9 minus 4x raised to the power of 6, then plus 50. Now you require to find out dy over dx. So here, when you apply the derivative change of dy over dx, would be equals to the derivative change of this function or the function, that is d over dx, then x raised to the power of 9 minus 4 x raised to the power of 6 then plus 50. This is like to say when we apply the derivative of this function, it will give you dy over dx is equal to, we differentiate with the values here. This will be equal to 9x, then 8 minus 1. We take out 9 minus 1, which is equal to 8, minus 24. 6 times negative 4 is 24x, then 6 minus 1 raised to power 5. This, when you apply the derivative change, the answer will be equals to 0. So this will be the answer. Then example number 2 on what is known as subtraction rule. For example, another example, if then y is equal to 20x raised to power cubic minus 2x raised to power 4 minus 4x minus 50. So when you apply, you find out, then you have to find out dy over dx. This will give you dy over dx. This will give you this function over here. You differentiate it, it will be equals to 3 times that 20 is 6x. Then take 3 minus 1 raised to power 2 minus 8x. Then 4 minus 1 is equal to raised to power 3 minus 4. So this will be the answer. Since when you apply the derivative change on constant number, its answer is equal to 0. Now after taking that, let's come to the product or multiplication rule. That is rule number 6. So let's come to what is known as product rule on multiplication rule. Product rule, multiplication rule. So actual on this rule, you need to understand that the derivative of the product of the two functions is equal to the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. For example, if you consider this function over here, if u is equal to function of x and v is equal to g over x, these are the two functions. Then are the two given functions. If these are the two given functions, then d over dx, u times v will be equals to the u times the derivative of dv over dx plus then again v. Take out v as t, then the derivative change times derivative change of du over dx. So this is the form actually the common way that we apply under what is known as product rule or multiplication rule. Let's consider an example on product or multiplication rule. The first example. So if y is equal to bracket 3x raised to power 2 plus 5, then 5x raised to power 3 plus 7. Now we require to find out dy over dx. Now let's consider a utility function that is 3x raised to power 2 plus 5 and v which is equal to 5x cubic plus 7. So solution. When we actually, how do we solve this? We apply the derivative change by finding out the u. We have the function like this, then we find the dy over dx. Now we are shown to write out our u. Let's write u then as 3x raised to power 2 plus 5. This is u, and v is equal to 5x raised to power cubic plus 7, as you observe. So after writing that, now let's apply the derivative change of du over dx. But that will give you out 6x. The derivative change of dv over dx will give you equals to 15x raised to power 2. Now for that case, now let's plug to our formula, to our common formula. Now let's apply our formula from what is known as product rule multiplication rule, that is equal to d over dx, then times uv is equal to u then dv over dx, then plus v times du over dx. Now when you apply this formula here, we actually plug in our value. for u and v. So this means that our u we have with this one, and v we have the derivative change of d over dx we have, that is 6x, dv over dx we have, that is 15x squared. So from that case, now when you plug it to our formula, dy over dx, then let you plug u. Now when you plug our u here, will give you from the function that is equal to 3x plus 5. Then we times what is known as dv. We times our dv over dx. Our dv over dx is 15x cubic. X raised power of x 15x squared. Then for that case, now we plus our v. We have our v, that is 5x cubic plus 7. Then times dv over dx times du over dx. Our du over dx is equal to 6x. Now for that case, now let's plug in our value. Our dy dx will be equals to, so after plugging this value here, let's plug our value inside. So this is our brackets, as you see. So we times this inside. Here it will be equals to 45x 45x raised power 4. When you times this one, it will be, this since here exponential of 2, it will be 45x raised power 4. Then plus times this one will give you 75x raised power square. Then plus, let's you plan 6 times 5x raised power cubic will give you 30x raised power 4. Then plus 7 times 6x, that will give you 42x. So here our dy dx will be equals to, it will be equals to, now let's take the like terms and correct together the like terms. So we take out, we have 75x raised power 2, we have 30x raised power 4, and we have 45 raised power of x squared. So when you take this one and this one, then you correct the like terms as you observe, this would give you us again 75x raised power 4, then plus again 75x raised power 2, then plus 42x. So this will be the answer. So let's also continue with another example on solving derivative by using of product rule or multiplication rule. Another example, that is example number 2. Then you require to find dy over dx if now y is equal to x raised power 4 plus x raised power cubic bracket then x squared plus x. We do the same procedure. Our u will be equals to let out u, which is equal to this figure over here, that is equal to x raised power 4 plus x raised power cubic. Let out our v, that is x squared raised power x. Apply now the derivative change of this function, that will be du over dx will be equals to this will give us 4x raised power 3, then plus the x raised power 2, and dv over dx will give us 2x plus 1. So for that case, now we may decide ourselves to plug into our value, to our formula, that is du over dx. V is equal to u dv over dx plus v then du over dx. Now when you plug out this figure here, this will give you now dy over dx is equal to u. So when you plug it our u, that will give you our u we have, which is equal to x raised power 4 plus x raised power cubic times dv over dx, that is equal to 2x plus 1. Then we plus again v, the constant v that we have, that is equal to x squared raised power of plus x, plug in the value, plug into the du over dx, that is equal to 4x raised power of 3 plus 3x raised power of 2. So this will give you dy dx is equal to, so when we multiply this figure over here, and when we multiply this figure inside here, we obtain 2x times x raised power 4 will give 2x raised power 5. Then we take out, after taking this, we take out this figure times this figure here. This will give you times, it will be, this will give you 2x. So when you take out x 4 times 1, it will give you x raised power 4. Will give you x raised power 4. And when you take out x cubic times 2x, that will give you, if you x from, so then 2x raised power of 4. Then when you take 1 times x cubic, that will give you x cubic, that will give you x cubic. Then plus, when you take out this figure here, x squared plus 4x raised power 4. So then we consider take x cubic times 2x raised power of cubic will give you x raised power of cubic as you observe. Then we take out 2x raised power of 2 times that figure over there. So when we take out this figure here, we take out x squared plus this figure here. This will give you 4x raised power of 5. Then plus, when you take out this figure times this figure here, we actually obtain out 3x raised power of 4. Then plus, when you take out x times 4x raised power of cubic, it will give you 4x raised power of 4. And when we take out 3x squared times x, this will give you now 3x cubic. So this will give you 3x cubic. So this is like to say, when we correct the like terms of this function here, we obtain out 6x raised power 5 plus 10x raised power 4 plus 4x raised power cubic. This will be the answer. So you correct out these like terms, you did out these like terms as observed, this and this, and actually deal with this and this as well. So when you correct them, you obtain 6x raised power 5 plus 10x raised power 4 plus 4x cubic. This will be the answer. For that case, now let's come to quotient rule or division rule. Let's come to quotient rule, or what we call the division rule. So what we call the quotient rule, or call it a division rule. So under quotient rule or division rule, what you need to understand is that the derivative of a quotient of two functions is equal to the denominator multiplied by the derivative of a numerator minus the numerator multiplied by the derivative of the denominator, or the divided by the square of the denominator. For example, if you have, if u y is equal to u over v, whereby u is equal to function of x and v is equal to vx, then our dy over dx, and that form will give you the form of v over du over dv, then minus u over dv over dx. So the answer here will be equal to du over dx minus u dv over dx over divided by v square. So this actually form a formula that we apply under what is known as division rule. So, for example, let's consider an example. If y is equal to x plus 1 divided by x minus 1, then we require to find out dy over dx. So when we apply the formula from this solution, it's like to say that from our formula that dy over dx, that is quotient rule formula. We normally take out dy over dx is equal to v times du over dv minus u dv over dx over v squared. So when you apply our value data here, this will give out uh, this will give out what is known as d over dx is equal to u. Let's consider to take out our u. So when you consider to take out our u, this will give out our u, that is x1. Since this is our u and this is our v, so we consider to take out our v, which is x minus 1 bracket. Then we take out d over dv. That we take out with times. It's like to say that we times out the dv, what we call du over dx. We times it over du dx. When we times out du dx over there, it's like to say you take out what is known as u, which is x plus 1. Then we apply the linear change of du over dx, which will give you 1. So here it is times 1 and minus u. Utility function, that is x plus 1. Then we times, it is x minus 1. Then we times dv over dx. So our dv dx, our v is this one, which is equal to x minus 1. The derivative change of du over dx is equal to 1. So when we take out also, we times 1 here. Then we divide by v square. Our v square we have is this one, x minus 1 base power square. So this equation here, you may choose to simplify it so as you can obtain the actual value. So you plug in 1 times x minus 1, you plug in 1 inside to see what will happen. It will be now dy over dx is equal to 1 times x minus 1. That will give you x minus 1, then minus again x plus 1, then over x minus 1 raised power square. This will be equal to this, and this will cancel out. X minus x and b with negative 1 and plus and positive 1. So when you deal with this figure here, you will come to observe something. This here will be equal to negative 2. This you will minus this 2x, that is x minus x. That will minus, and you take out negative 1 and negative 1. So our x minus x will cancel out. It should be negative 1 minus 1. That will give you positive negative 2. So for that case here now, our answer will be negative 2 over, we minus x minus 1 raised power 2, that is x minus 1 raised power 2. This will be the answer. Second, now if y is equal to x raised power 4 over x squared, when we require to find out our dy, over dx, this will be equal to now our u, which is equal to x raised power 4, and our v, which is equal to x squared, and our du over dx is equal to 4x raised power 3, and our dv over dx is equal to 2x. Now for that case, when you plug into our formula, so when we plug into our formula, for actual, that is du over dx is equal to du over dx is equal to v du over dx minus ud v over dx. The answer will be equal to now dy over dx is equal to v, which is equal to x squared times du over dx, that is 4x cubic minus u, then times dv over dx, our u, which is equal to x raised by 4 times dv over dx. Derivative change of dv in respect of x is 2x, then divide by the v square. You don't have to forget the v square. Now our v square is x raised by 4. So when we actually solve this equation here, down here, you come to observe. So our v square is x raised by 4, as I told you. So you look the way if you can simplify the equation more, because dy over dx is equal to plug in this value here inside, plug in this value here inside. What will give you? It will be now 4x raised by 5 minus 2x raised by 5 over x raised by 4. So this is actually give you 2x raised by 4 over x raised by 4 if you simplify that. This will give you that one. Another rule is what we know as chain rule or function rule. Another rule is what is known as chain rule. Call it a chain rule or function rule. Other function is called the chain rule or function rule. So under function rule, if y is a function of u, where u is a function of x, then the derivative of y with respect to x is dy over dx is equal to the product, the derivative of it. So if y, for example, let's consider an example here. If y is equal to function of u, whereby u is a function of x, if y is a function of u and where u is a function of x, then this will start to say dy over dx will be equals to du is equal to dy over du times du over dx. Let's consider an example. If y is equal to 7u plus 3, and whereby u is equal to 5x raised by 2, now you require to find the du over dx. So from our formula here, dy over dx is equal to dy over du times du over dx. So from this function here, we have the utility function, that is this one, and y, which is equal to 7u plus 3. So when you apply, for example, the derivative change of du over dx will give you 10x. When you apply the derivative change of dy over du, will give you dy over du will give you 7. So for that case now, when we plug it to our data formula, this will be now dy over dx is equal to dy over du, that is equal to 7 times what is known as du over dx, which is equal to 10x. So the answer here will be equals to 70x. So dy over dx is equal to 70x. That is how it is. Now let's consider an next example. If y is equal to z raised to the power of cubic plus 10 and z is equal to x raised to the power of 7, then find dy over dx. This will give you now dy over dx is equal to dy over dx. Dy over dx is equal to what is known as du over dz times dz over dx. So from this utility function of y is equal to 7 raised to the power of 10, you may apply derivative change of dy over dz. That will give you 3z raised to the power of 2. And from the function of utility function, that is z is equal to x raised to the power of 7, you apply the derivative change of dz over this factor of dx, it will be 7 6 raised to the power of 6. Now after taking this, you may apply it to your formula. To our formula, it will be now dy over dx is equal to du over, the du over dz. That's like to say that we take out dy over dz. That will give you dy over dz will give you 3x raised to the power of 2. Then e times exactly with dz over dx, that will give you 7 raised to the power of 6. So when you apply more multiplication rule over there, without forgetting on what we have done above here. So when you subtract, you sub x squared with get, we obtain more other results as you continue apart from this. So when you make that and simplify more, it will sometimes result to 3x x raised to the power of 7 over 2 minus 7 x raised to the power of 6, which will give you something like this. 7x raised to the power of 6 is equal to 21 x raised to the power of 20. So this is how actually what we apply on solving derivative by what is known as chain rule or function rule. Now this mark our end. Let's check on other videos so as you can learn on other functions as well. Bye bye and welcome to DC Economics.